Oh, I just didn't turn it on.
Wow. Were you recording us this whole time? Were you recording us this whole time?
No, I didn't turn it on. I wasn't
Oh,
recording it.
oh, I thought it was backwards.
One of these days I'm going to leave the room and leave it recording.
Do you upload them on YouTube like every day?
What's that?
Do you put them on YouTube like every day?
Yeah.
Oh wow.
I don't know if anybody's watching.
We lost it.
How many people YouTuber?
Do you get paid by YouTube? Because YouTubers get
10,000
I'm not
subscribers.
going to make you guys look watching ads and things like
Why not? You get to make the money. You could probably make like a cent per minute.
Oh, with the tens of views I have on some of my videos? God, I'd be rolling in the dimes. Wow.
The tens of views.
I'll take that one.
It's okay, Jeff, it's math.
All right. What do you have to do with 16 first? Something squared is that thing times itself. And now you can attack it with repeated distribution. So 3x gets a turn. What's that?
9x squared minus
15xy minus 15xy plus 25y squared.
So you get 9x squared minus 30xy plus 25y squared. You guys see that? Bless you. Vividly, all right. In living black and white. So what about this one here? That's why I truly hate FOIL, because if you teach FOIL, it feels like this is a different problem. It's not a different problem. It's the same thing. Z gets a turn, and it goes through. Z times Z squared is Z cubed. Z times 2Z. 2Z squared. Z times 5. 5Z. Minus 2Z squared. Minus 4Z. Minus 10. So you get Z cubed. The Z squares go away. Plus Z minus 10.
good.
All right. Don't look at 18 yet. We haven't talked about 18.
Whoa.
Woo, division, oh shit.
All right. What's happening? Oh, don't, again, we'll talk about 18. We haven't talked about it yet.
That looks scary.
I love it, guys. Looks scary?
Yeah, probably.
Wow.
No.
This is page 120. Page 120. Part of me hates that they have a special section for this, but I just kind of quiet that part. It's nothing different, to be honest. You just do it like always, but there is a little something interesting, and it's going to help us when we get to factoring. So do these three, and see if you can't see a pattern emerge.
See if you can't see.
See if you can't see, exactly. It's sort of like I saw the sign, and then I opened my eyes. How the hell did that happen? Do you remember this sign? It's always bothered me. I saw the sign and it opened up my. Something's out of order. $120. $120. All right. Should be relatively quick, hopefully. So this, again, is just the same old thing. There's a slight interesting thing that happens when it's the same terms with a different sign in the middle. So x times x, x squared, x times -2. 2 times x.
-4.
So of course what happens there?
X squared is -4.
Yeah, these go away. Some of you guys might know the phrase difference of squares. Some of you guys might say, I know those words. So what's going to happen on number 2? Same thing. So yeah, y squared minus 4y plus 4y minus 16, just to cut to the chase. Right? So of course the middle terms die because of the same stupid numbers and letters, different signs. So of course that same thing's going to happen every time. So you go y squared minus 16 here. You get 9 minus 3w plus 3w minus w squared. So I get 9 minus w squared. So you don't have to commit this to memory. Because like I said, math isn't just about memorizing everything. But what pattern do you see emerge? What would the shortcut be if I wanted to make a shortcut?
It's just a squared plus
Yeah.
Minus b.
Now, people that try to memorize that, they try to use it too often. So it's better just to do the repeated distribution and then let them cancel if they want to. I don't know if you guys see what I'm saying. All right. But this is going to become very important when we do factoring this. It'll be easy to take this back. It'll be easy to factor it into its parts because we know this. Okay. Screw all that. Oh, I don't even know if I want to do that. I mean, is this different than anything we've done before? No, we've done that kind of thing before. They're trying to develop a general formula which I don't necessarily like. Because then it makes it feel like you're supposed to memorize all this stuff. When really, how do you do these? You just write it twice and FOIL it. Right? Repeated distribution.
If Jeff don't like it, you don't like it.
Okay. All right. Yeah. So do all the rest of that stuff. Oh, I like it. Oh, this I like. Oh, let's see. Oh, yeah. Here we go. Just a few more things today, guys. We're kind of desperately have to slow me down if something's not making sense, so I can deal with that. Normally, what I say is, if I'm going too fast, slow me down. If I'm going too slow, deal with it. Kind of chugging right through this stuff. So please, dear God, in lab or something, let me know if something doesn't make any sense or whatever. You have to. You have to. We're going to do a little bit more, and then we'll probably head out a little early. And those of you that have lab, oh well, I'll see you there at 11. but the rest of you guys can head out. Not yet. Whatever. So look at this one here. What's the degree of this first term?
Second degree. Oh, one.
Yeah, it's a first degree because I see 1x. Cool. What's the degree of the second term?
2.
Good. It's the second degree because how many letters do I see? 2. An x and a y. And of course, this guy is good old second degree. So what's the degree of the whole polynomial?
Second degree.
Second degree. It's the highest degree I see. Alright, I like it. So then you guys do this one for me, the same way we just did it. Sheesh, what the hell? Can't believe this guy. Asking us to do shit. Let's see. 1, 2, 3, 4. Polynomial. Exactly. That's where they just got tired of this. Oh, polynomial. All right. So what's the degree of that first term?
4.
Good. 1, 2, 3, 4. I see 4 total.
Very.
4 total letters. This guy, of course, is easy. Third. Second. Yeah, 2, 4, 6. So what's the degree of the whole thing? 6. That's the winner. Winner, winner. Chicken.
Wait, I don't get it. How is that? Wouldn't it be 1, 2, 3, 4, 5, 7?
For which one?
That one, yeah.
2 A's, 2 B's, 2 C's.
Aren't you counting the...
It's for the variables,
variable?
not for the exponents. So be careful, guys. What's the degree of this term here?
4.
Second degree.
Third degree.
Fifth degree.
How many X's do you see in there?
1.
How many Y's?
1.
So it's 4th degree, ain't it? What looks like a 4?
Well, now that just looks like a double. Is that a 6?
So this,
Doesn't matter.
that is just a number. So don't look at the exponents on everything. Just look at how many total letters do you see. I see 4 letters, 3 B's and an A. So that would be a 4th degree. Okay. Do this one here. See this one here?
There should be two separate, right?
What is it?
There should be two separate things that we're doing here.
No.
Okay.
How many variables are in, how many,
We did it.
hang on,
Yeah, I
so
was just wondering.
there's an X and a Y, right? There's how many unknowns are there in that expression? 2. So how much information do I have to give you so you can fully do it? 2 pieces of information. So this is one question with one answer. X is 2, so put a 2 where X is. Y is -3, so put a -3 where Y is, and you're going to get a number. Because now you know all this stuff, right? You've seen this kind of thing before. You've seen this kind of thing before in 88. All right, guys, let me see. So let me rewrite this. 2 times what? 2. Plus 3 times
2.
2 times
-3.
minus
-3.
2 times 2 is
4.
3 times 2 is 6 times -3 is minus 18. -3 squared is
Positive 9.
+9. There's a minus sitting there.
Oh.
So minus 9.
-5.
That negative and that negative cannot cancel each other because you have to square first. And when you square, that negative is gone. You can see that.
Yes.
You can't kill these negatives because you're not allowed to multiply before you exponent, right? Just to verbalize that word. And of course, what do you get there?
Negative 23.
Negative 23. Okay. But, so at the very bottom, when you have multiple variables in a polynomial, like terms gets a little bit more complicated. You just have to be a little more careful. You can't combine, so what would be like terms with that 2xy squared? Well, what's it got in it? It's got an x and a y squared. So like term says has the same variables and the same amount of each variable. So is there, let's just do this in order, I guess. There's a plus in the middle, right? So I don't have to worry about distributing anything. Do I see another x squared term?
Yes.
There. All right, so then I get what?
4x squared.
That's crazy. Do I see another term that has 1x and 2 y's?
4x.
Way over there. I like it. You guys see what I'm saying? I can't combine this and this. Why not? Because this is 2 of these and that's 4 of those. You guys see that? To be like terms, you have to have the same letters and the same amount of each letter, right? So this term I'm looking at right now has 1x and 2 y's, so it can only go together with something else that's got 1x and 2 y's. So how many 1x, 2 y's do I got? Negative 2 plus 4 is, I got 2 1x, 2 y's. I can't consolidate it unless they are exactly the same at the core of it. Xy squared can only go together with another xy squared. Now what about x squared y? Is there another one of those?
Yes.
Yeah. Where are you? There you are. So how many x squared y's do I got?
6 squared 9.
Any y's? Any y's? No. Poor little dude's all by himself, so minus y. Any more xy's? No. Any more x's? No. So those just get collected at the end. They're the lonely guys. You know what to go with. You guys see that you got to be a little more careful. Have a button that controls the clock. No. All right, now let me show you something because they don't do this, and I remember I always have to show this because this one semester I had this one student just arguing with me. It was awesome. Yeah. Alright, zoom out. Are there any like terms in that expression?
Yeah. Well,
Yeah.
yeah,
The correct answer is yes, there are. What's the first term got? 2 A's, 3 B's. Is there anybody else who's got 2 A's and 3 B's? Yes. Because A squared times B cubed is the same damn thing as B cubed times A squared. Is everybody cool with that? And boy, let me tell you, I remember this very clearly. I think it was like my third semester teaching, and I was thinking to myself, what the shit have I done to myself? I was like, A times B is the same thing as B times A. No, it isn't. Oh, okay. 7 times 4 and 4 times 7. That's a coincidence. I can't remember. It was crazy. It was crazy. I mean, she kept it going for a while. Everybody in here understands that multiplication doesn't give a shit what order you do things in, right? 5 times 7 is the same thing as 7 times 5. So those are like terms. I just wrote the last one out of order. Normally we write them in alphabetical order, so it's easier to identify what like terms are. Do you guys see that? So it's just somebody just didn't write that last one in alphabetical order. So if I do that, it just becomes a lot easier to see. Make sure everything's become a 3 there. Now it's much easier to see that those are like terms. In fact, those are in fact like terms. So then you get what? 6.
6 squared, A squared, B cubed.
There's got to be a 3 there. I like it. Let's see. Where was I? That might happen a few times too. Where was I? Good Lord. Here I am. So do number 2 and 3, and then I'll let you guys out. Not too early. That's too bad.
It's okay.
Huh?
It's okay.
It's okay. Marco speaks for the whole class.
Marco. You guys, while you guys are finishing that those problems,
You guys heard about the asteroid that flew within the orbit of the moon, that closer to the Earth than the moon is. Flew past us basically early this morning. So they didn't even know it was out there until relatively recently. That'll make you all feel good.
Yeah.
Bruce Willis is getting too old. Send him up there.
Oh, do it.
So the degrees both have to be the same for it to be a like term.
They have to be the same letters and the same amount of each letter. You like it? You're good? Alright, so first thing you gotta take care of though in this first problem is what?
The -1.
Stupid negative. Oh shit. Oh boy. Oh, that's good. So minus that, and then minus that becomes plus. Oh boy.
Might have to see them out.
There we go. Of course, some of you guys look at this and you go cross-eyed or whatever. But that's where you got to train yourself. When I see this, I do understand why it looks like, oh God. But at the same time, I look at it as, okay, there's 3x squared y's. Any more x squared y's?
-2x.
Yeah, there's another x squared y group. Any more x squared y's? No. So 3 of these minus 2 of these is
Just
x squared y. I had 3, I took 2 away, I got 1 x squared y left. So any x cubed y squares?
Yes.
There it is. So I got minus 2x cubed y squared plus 1 x cubed y squared is negative
That's
x cubed y squared. Any more x squared y cubes?
no.
Aw, poor little Jew. Any more y's?
Well, yeah. It's just y.
So negative y plus 2y plus y. Oh, I have to write this poor little Jew. Jeff. Sorry, little lonely dude. Almost forgot you. Even though there's nothing to go with, he's still part of the answer. Let's see. And then this guy. He's the last lonely dude.
So it doesn't matter what order you write it in.
At the moment, no. And especially with multiple variables, because which variable do I use to do descending order? That's a question for later. Real quick, number 3. So I get 2 times 2, 4. X times x squared. Y times y. 2 times negative 1. X times x. Y times y. Are you guys with me here?
Yeah.
This is pretty much how you do this for yourself. 2 times 1 is 2. X times x squared is y. No y to go with, right? I'm just going to keep going. I've lost value.
Minus 2x squared.
Yeah, minus 2x squared y squared. I should just line them up. Minus 2x squared y squared. Negative y times negative xy is
xy squared.
positive xy squared. And then negative y times x squared.
Negative x squared.
Negative x squared y. So I just had one little piece of like terms. I got 4x cubed y squared minus 4x squared y squared plus 2x cubed y plus xy squared minus x squared y. Good Lord.
You lost it.
That was a little fast, but oh well. Bless you, bless you, bless you. Alright guys, I'll see some of you guys in a few.
try this
Yeah, if you go to the office.
No, actually, they
Oh yeah, thank you.
But still, that's